In this video, we are going to talk about the derivative of logarithmic function, okay? In college algebra, you have seen the logarithmic function, right? Do you remember? How do I write? If there is x equals to a to the y, how do I write this using log? You write y equals to log of the other side, and this base goes to the base, right? So the exponent equals to log of the other side, and the base goes to the base of the log. How do I read this? I read this as y equals to logarithm of x with base a. Logarithm of x with base a, okay? And also we saw that the log with base e is called natural log. Do you remember that? If the log has base 10, we call common logarithm, and the log with base e is called natural log. And we write log of x with base e as, do you remember how do I write that? You write that is ln x, okay? If there is a base e, you don't have to write that base. You just write, instead of log base e, we write ln. That means natural log, okay? Natural log of x. That's how you write, okay? And we see some of the properties of the log, and these properties are true for any base. So I wrote the formula for log base e, I wrote the formula for natural log, but these properties are true for any base. The base could be a, b, c, any number, okay? But that should be positive number, okay? So it says natural log of x plus natural log of y is equals to natural log of x times y. Meaning, what does that say? That says sum of the logs is equals to log of the product, okay? If you add two logs, then how do I combine those two into a single log? Is you write ln, a single log, and then x times y. By the way, here in this case, okay, so the x must be positive, and then a must be positive as well, okay? X must be positive, a must be positive as well, okay? Now, natural log of x minus natural log of y is equals to natural log of x divide y. So the difference of two log is basically log of the quotient. If there is natural log or log of x to the n, if there is ln x to the n, natural log of x to the n, that n you can bring that to the front and then write n times natural log of x. You can write that way, okay? And a to the x, the last property here is a to the x. Any base a to the x can be written as, the a must be positive, again a must be positive. A to the x can be written as e to the x natural log of a. If you want to change the base a as base e, then you can write e to the x ln a. What is e? E is an irrational number whose value is almost 2.7. Okay, by the way, here as I mentioned, a must be always positive, okay? A must be always positive. When a is positive, any exponent of a will be positive as well, right? So x will be positive by itself, but a needs to be positive, okay? So you can write a needs to be positive. That is must, okay? Now let us use these properties to do some of the examples. If there is ln root x squared plus 1, how can you write this? How can you simplify this? I can write this ln and then x squared plus 1 to the 1/2. I can write this that way, and then you can simplify this as 1/2. This power goes to the front, right? The exponent goes to the front, and then ln x squared plus 1. You can write that way. How about here? You can break this into the two logs, right? You can write ln 1 minus x and then minus ln 1 plus x. What did I do here? Because there is the quotient, this difference can be combined to quotient, and then quotient can be broken down into the difference. Similarly, the sum can be combined into product, but the product can be broken down into sums and so on, okay? So how about here? You can write this as ln, and then you can write x squared minus 1 over x to the 1/2, right? You can write 1/2 to the front and then write ln x squared minus 1 over x. Now how do you simplify that? Is you can write basically 1/2, write down bracket. This is quotient, right? So you can write ln x squared minus 1 minus ln x. That's it. Okay. So the last one is, there is the product, right? And then the second term on the product has the root. So how can you write that? You can write this as ln x plus ln root of x cubed minus 5. Okay. Now, what did I do here? There was product. So the product can be broken down into sums. That's what I did, sums there. And this can be written as ln x plus, if you write this in the exponent form, that 1/2 will be there, right? So you can write 1/2 and then ln x cubed minus 5. You see that? So what's going on here is, basically what we did there is, we wrote that as, this can be written as x cubed minus 5 to the 1/2, because the root means the exponent 1/2, and then that 1/2 went to the in front of the log, right? And then natural log, and then you write the remaining thing inside the parenthesis. Okay, guys? Okay. So one limit formula we will be using on this section is limit x tends to 0, natural log of 1 plus x to the 1 over x equals to 1. And how did I get that formula? We will prove this formula in section 5.6. Section 5.6. We will do this, okay? But for now, we will use this to find out the derivative of fx equals to natural log of x. Alright? So let us find out the derivative of natural log of x. So we want to, this is our main goal of this section, right? We want to find out the derivative of natural log of x. Do you remember the formula for the derivative? What is the formula for f prime of x? It is limit h tends to 0, f of x plus h minus fx divided by h. That is the formula, right? Let us plug in those values. What is that? Natural log of x plus h minus natural log of x over h. That is f of x plus h minus fx over h, right? So this is written as limit h tends to 0, right? So how can you combine those two logs? Natural log of x plus h over x divided by h. You see that? What did I do? It is natural log of, look at the property number 2. Natural log of x minus natural log of y. If you combine those two into a single log, you can write natural log of the first one divided by the second one, right? That's what I was doing. Natural log of x plus h minus natural log of x. So this can be simplified as natural log of 1 plus h over x. Do you understand this? Over h. What did I do here? Excuse me. So you can split that, right? X over x is 1 and then plus h over x. That's what I wrote here. Okay. Now I want to use that formula. Natural log of 1 plus x. But instead of x, we have h over x. So we need there 1 over that h over x, right? So what I want to do here is, I want to write like this. Limit h tends to 0. Okay. So what I want to do there is, I want to do this. Natural log of 1 plus h over x divided by, I want to do h over x times x. What did I do here? Because I want to match that. I want to write h, since I got h over x here inside the log, inside the parenthesis, I want to get exactly the same thing. And you will know why do I want to get that. You will know that later, okay? But for now, I want to, since there is just h in the denominator, I just divided by x and then multiplied by x, assuming that x is not equals to 0, okay? So what I want to do next is, I want to write this way. Limit h tends to 0, right? Can I write this as like x over h and then natural log 1 plus h over x divided by x? What did I do? Look at this. What is happening there is, there is natural log of x over h over x, right? So this x over h over x can be written as the top, whole the top thing, that thing times x over h, because this is like fraction of fractions, right? there is a numerator and this is the denominator. So if the denominator has the fraction, right? So if you want to write that in the product form, you can write the top fraction or whatever in the top times the reciprocal of the bottom. So the top times the reciprocal of the bottom is x over h. That's what that x over h I wrote to the in the front. Okay, of over x is as it is there. So what I want to do next is, so let me use different color there. So what I want to do next is, I want to write like this: natural log of 1 plus h over x to the x over h divide by x. Do you agree with this? What did I do? So the third property, this property says that if there is anything in the exponent, you can pull that down in front of the log, right? Similarly, if there is something in front of the log, you can go the other way too. If there is something in front of the log, you can move this to the exponent. Okay, that's what I did. There is something in front of the log, and then I moved that to the exponent. That's what I did. Okay, so what I want to do next is, the limit is h tends to 0, right? So the limit is basically h tends to 0. So what can I write this one then? So since this is h tends to 0, you can divide by x on both sides. What do you get? You can divide both sides by x. Okay, and then this can be written as into that form. Okay, let's do that. So this can be written as, let me pull that x out, because that x doesn't have h, so I can pull that out and then write the limit h tends to 0 natural log of 1 plus h over x to the x over h. So what did I do here? Here, what I did here is I'm trying to use the formula, okay? The limit h tends to 0, limit h tends to 0, okay? And then natural log of 1 plus something, 1 plus some quantity, and in the exponent, the reciprocal of that, okay? So look at this. Limit h tends to 0, natural log of 1 plus h over x. There is some quantity, and in the numerator, in the exponent, this has the reciprocal of that quantity, h over x. The opposite, the reciprocal of that is x over h. In that case, the limit will be 1. Is basically, this is 1, right? So what is left is 1 over x times 1. That is basically 1 over x. So what we can write here is basically derivative of natural log of x is basically 1 over x. Look at this. They are matching, right? The derivative of natural log of x is 1 over x. But if they don't match, how do you do that? You do 1 over u times the u prime, right? If there is natural log of u, but you are finding the derivative with respect to x, then it will be 1 over u, like that, right? The derivative of natural log is 1 over whatever there, and then times the derivative of that thing, times u prime. Okay,